Welcome back. Now we are on indices and logarithm. We are now on indices and logarithm. So let's start with indices first. Indices first, then before we move to logarithm. So now these are the laws of indices. All these are the laws of indices. Everything you are seeing here are the laws of indices. So it is very, very simple. It is very, very simple. But you have to know it offhand. You have to know it offhand. Like, it will help you all through your journey in mathematics. If you can understand these laws of indices, it will help you. So I'll just explain the laws to you. Then in my next video, we'll solve examples together. Now, law one, the first law of indices. When we have a raised to power m, this is a raised to power m times a raised to power n. What does the law says? This is the base number. Why this is the index? When you have, let's say you have a raised to power m, this is called the base number. Don't forget why this is called the what? Index. This is called the index. So take note. So this is the base number, why this is the index. So a raised to power m multiplied by a raised to power n. What does the law says? The law says when they have the same base number and it is multiplication sign, what do you do to their power? You pick one base, that will be a. Then if it is multiplication, what do you do to their power? What do you do to the index? You add. You get? You add it. So that will be a raised to power m plus n. Now this is what we're trying to say. Let me just solve one small explanation about that. Now let's say we have 2 raised to power 2 times 2 raised to power 3. Now they are the same. Look at it. The base number are the same. When the base number are the same, what do? You pick one base number, then 2. When it's multiplication, what do you do to their power? You add. That will be 2 plus 3. Abi? So that will give us 2 raised to power 5. Now let's break it down and see if we get the same answer. 2 raised to power 2 will give us what? 4, right? Then 2 to the power of 3 will give us what? Will give us 8, right? So 4 times 8 will give us what? 32. Now 2 to the power of 5 will give us what? Will give us 32, right? That's 2 in 5 places. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2 is what? 82. So it means this 2 to the power of 5 means 2 in 5 places. You see, it's still the same answer. So laws of indices will help you break a long journey for you. It will help you break it down. Sure you get. So that is that about the first law. Now let's move to the second law. The second law says when we have a raised to the power of m divided by a raised to the power of n, when they have the same base, what do? You pick one base. If it is division, what do you do to their power? You subtract. That will be a raised to the power m minus n. Now for example, let's pick one. Let's say 2 to the power of 3 divided by 2 to the power of 2, right? Now, laws of indices. The second law says that what? 2, you see they're having the same base number. So I'll pick one base number. Then if it is division, what do I do to the power? I'll subtract. That will be 3 minus 2. I'll subtract their power from each other. So you get. Then that will give us what? 2 to the power of 1. Abi? So 2 to the power of 1 is what? It's still 2. Now, let's do it the normal way you are to do it. 2 to the power of 3 means 2 in 3 places. That will give us what? That will give us 8, right? Divided by 2 to the power of 2 will give us what? Will give us 4. 8 divided by 4 will give us what? Will give us 2. You don't see the same answer. Sure you understand? So that is just that about the second law of indices. Now, coming to the third law now. The third law says when I have a raised to the power of m in bracket, then I have another index outside which is the power of n. What do? I'll multiply both power together. That will be m times n. Now what are they trying to say? Let's say I have 3 to the power of 2 and I have 3 outside. So what do? I'll just say pick. That will be 3. Then that will be what? I'll multiply the power together. That's 2 times 3. And that will give us 3 raised to the power of what? 6. Do you understand? So that is that about that. So if you are not sure, let's try it. 3 to the power of 6 will give us 729. Abi? 3 to the power of 6 will give us 729. Now let's solve this one. Now 3 to the power of 2 will give us what? Will give us 9. Abi? 9 to the power of 3 will give us what? Let's check. 9 to the power of 3 will give us what? It is still the same 729. Here you see, it is still the same 729. So you see that law of indices is also, it also helps. It also helps. Just in case when you don't have calculator, so it also helps to make your work easy. Now, let's go again to the fourth law. The fourth law says when I have a raised to the power of negative, when I have a negative power, let's say a raised to the power of minus m. Now, when you have a negative power, take note. Anytime you have anything raised to the power minus, another way you can write it is what? Another way you can write it is what? 1 over. Anytime you have anything raised to the power of minus, raised to the power of minus, another way you can write it is what? 1 over, then that will be a raised to the power of what? M. Then, now, when you are bringing the m, now, when you are bringing the power here, it will not carry a negative again. Because that negative, another way to write that negative, that power negative, it is already 1 over. So when I'm writing it here, I will not put the negative again. So don't make that mistake. So when I have, let's say for example, I have 3 to the power of minus 2. Sure you get. If I want to rewrite it now, I will write it as what? 1 over, because anything raised to power minus, another way to write anything raised to power minus is what? 1 over. So that will now be what? 3 to the power, what is the power now? 2. The power will now be 2. It will not be minus 2 again, because that minus is gone, because you've written it as 1 over. Do you get? Now will give us 1 over, then 3 to the power of 2 will give us what? 9. Do you get? So please take note. So when you have something like this, I'm gonna write it and say 3 minus 2. That is wrong. Oh, it is wrong. It is very, very wrong. Now let me use this opportunity to explain. Now, if I have 1 over, let's say, okay, let me just use another one. Let's say I have 1 over 2 to the power of 3. Now, tell me now, just pause the video before I answer it. Just pause this video and tell me another way to write 1 over 2 to the power of 3. Another way to write it will be what? Just pause the video and just say it and see if it's actually the same thing with what I'm going to say. If I have 1 over 2 to the power of 3, another way to write it will be what? Another way to write it will now be what? 2 to the power of minus 3. Do you get? Because you see that now when I'm taking it up, then this power becomes backward. It becomes negative. Do you understand? So if I have 2 to the power of minus 3, if I want to write it, another way to write this negative power is what? 1 over, then I'll have 2 to the power of 3. So if I want to return it back, so you see that it's not having negative. So what will it be? It will now be, if I'm taking it up, it will now have minus, negative. So you get. Now, let me give you another one to solve. Let me say, I'm giving you 1 over 4 to the power of minus 2. Now, another way to write this would be what? Pause this video and answer it. Another way to write this video, another way to write this question will now be what? Another way to write this will be what? That will be 4 to the power of 2. You see that it is negative 2 here. Don't confuse yourself. I'm not trying to confuse you. I'm just trying to make you understand. Once you understand it, you are good to go. You can never forget it again. So you see that now when I'm having 1 over 4 to the power of minus 2, you see that when I'm taking it up, what will it become? Positive. So if I want to write something like maybe 3 to the power of 2, if I want to write it, maybe I can write it as and say 1 over 3 to the power of minus 2. It's still the same thing now. Because when I take it up back, this minus will change to what? Positive. So don't confuse. I'm not trying to confuse you. But if you know you're going to get confused, don't worry. Just let's forget about that one. But I know you will still need it. So that's why I try to explain it. But if you don't understand, just go over the video again. You will get to understand it. So that is that about the fourth law. Now, rushing to the fifth law. If you have anything raised to the power of 0 is what? 1. You know it. So if you have 100 raised to the power of 0 is what? 1. Don't let them confuse you. If you have 1,000 raised to the power of 0 is what? It's still 1. So if you have 1 million raised to the power of 0 is what? It's still 1. Minus 10 to the power of 0 is still what? 1. Here you get. So that is that about that. Now, the sixth law. X raised to power n multiply by, this is my x, so please don't confuse yourself. This is my x, this is my multiplication, and this is y, this is n. Now, x to the power of n multiplied by y to the power of n. Now you see that this part now, they're having different base but the same power. Different base but the same power. So what do? I'll multiply the base together, then the power will now be all in brackets, then raised to that power. Do you get? So it means, let's say for example I have 2 to the power of 2 to the power of 4 multiplied by 3 to the power of 4. They're having the different base number. So what do? I'll just say 2 to the power of 2 multiplied by 3, then all raised to the power of what? 4. That is the sixth law. Sure you get. So it's just very, very simple. Now the seventh law. If I have x raised to the power of n divided by y to the power of n, they're having different base number. So what do? Now that would be x divided by y. That's x to the power of n divided by y to the power of n. I'm just writing it. Sure you get. Now what do? They're having different base number but the same index. What do? I'll just say x divided by y, then all to the power of n. Do you get? So it's just very, very simple. Don't worry, we'll solve examples with this in the next video. Now going to the eighth law. If I have x to the power of 1 over n. Now this is where I need to just emphasize on this last one. I need to just emphasize on it so that once you get it, you are good to go forever. You are good to go forever. Now if I have x to the power of 1 over n, it means another way to write it is what? It is n square root of what? X. N square root of what? X. So let's use numbers for this. Let's say I have x to the power of half. X to the power of half. Now let's say the n here now is 2. I'm using it as 2. So what do I write it? X to the power of half. Another way to write it is what? Is square root of what? X. That one you don't have to put 2. Don't go and put 2 on top on that square root. No, it's just like they call it tautology, like repetition. Sure you get. So the square root already is already carrying that 2. So you don't need to put 2 again. So the square root already is already carrying that 2. Sure you get it now. So let's say for example I have x to the power of 1 over 3. Now here I can say 3 square root of what? X. You get it? This is correct. But if I have it as 2, the square root is already the 2 already. So you don't need to put 2 again. You don't need to put it again. It's just like repetition. Sure you get. So but if I have it as x to the power of 1 over 3, I can write it as cube root what? Cube root x. Now if I have it as x to the power of 1 over 4, now you see I can write it as 4 on the root raised to the power of x. You get? So take note of all these examples in your head. Sure you get. Put it in your head. Now, so that is that about that. So coming to the ninth law. If I have x raised to the power of m over n, how did I write it? That would be n square root of x raised to power m. N square root of x raised to power m. Let me just break it down for you. If I have x to the power of m over n, now you know I can write this as x to the power of m times 1 over n. Is it not still the same thing? M times 1 over n will still be m over n, right? So now you know if I have x to the power of any to the power of, let's say this 1 over n, what do we call it? You know, it's just like this first this eighth law. So what do we call it? You know, I can write it and say square root n square root of that x, abi. Then what is it having? It's having the power of m. So that's why you see it here. N square root of x raised to the power of m. You get it? So now let me use number for it also so that you understand better. Now let's say for example I have x, then I have 5 over 2. 5 over 2. Now you know what it will be. You know what it will be. Now that will be what? I can write it as x to the power of 5 times 1 over 2, right? X to the power of 5 times 1 over 2. Now you know 5 times 1 over 2 will still give me 5 over 2. So now another way to write anything to the power of 1 over 2, another way to write it is what? Another way to write it will be what? Square root of x, abi. Then what is it having? It's having raised to the power of 5. Square root of x, then to the power of what? 5. Now that is that about that. So if I have it as, let's say I have it as x 2 over 3. Let's say for example I have it as x 2 over 3. Now another way to write it will be x raised to power 2 times 1 over 3, abi. Now another way to write this raised to power 1 over 3. Don't forget it is what? Cube root, abi. Cube root x, then what is it having? Raised to the power of 2. I hope you understand it now. It's just very, very simple. Just very, very simple. Don't worry, when we get to watch the next video, we'll solve examples and you see how we're going to solve questions on it. You see how we're going to solve questions on it. So please, if you find this video helpful, do well to like this video, subscribe to my YouTube channel, comment, and share this video to your loved ones, share it to your friends, share it to your colleagues. Thank you.